Questions 1 through 4 on the 2020 Grade 12 Euclid Math Contest. If x is 11, what is the value of 3x plus 6 over x plus 2? 3 times 11 plus 6, and then substitute 11 in the denominator, and you get 11 plus 2. That is 33 plus 6, which is 39. This is 11 plus 2, which is 13. 39 divided by 13 is 3. What is the y-intercept of the line that passes through negative 1, 5 and 1, 7? All lines have the equation y equals mx plus b. So substitute this one, and we'll get some equations. So the first one will give me 5 is equal to minus m plus b. The second point, when substituted, will give me 7 is equal to m plus b. If I take these equations, just add them, I'll get 12 on that side, the m's disappear, and I'll get 2b. That allows me to solve for b. B is 6. Sub b equals 6 back into any of these. This one, for example, would give me 5 is equal to minus m plus 6, and therefore m is equal to 1. So that equation is x plus 6. Take out the y-intercept, you set x equal to 0, and when you do, you get y is equal to 6. The lines with the equations y is equal to 3x plus 7 and y is equal to x plus 9 and y is equal to mx plus 17 intersect at a single point. Determine the value of m. Well, let's let those two equal to each other. So 3x plus 7 will be equal to x plus 9. And that will give me 2x is equal to 2. Therefore, x is 1. All right. And sub x equals 1 back into either of those equations, and you should get the same. Y will be equal to 10. For both, it becomes 10, which is what you would expect it to be. All right, so now let's turn our attention to that and that, those two equations. So x plus 9 is equal to mx plus 17. Now solving for this, x minus mx is equal to 8. And that means when we factor out the x, it would be 1 minus m is equal to 8. And then x is equal to 1, so substitute that in, and then you just get 1 minus m is equal to 8, and therefore you would have m is equal to 1 minus 8, so m is equal to negative 7. And that pretty much means that this equation is minus 7x plus 17. When you substitute x equal to 1, you again get y is equal to 10 in this equation. So that point, not that we needed to write it out, is 110, but what they really wanted was the value of m, which is negative 7. The 3-digit positive integer m is odd and has 3 distinct digits. If the hundreds digit of m equals the product of the tens digit and the ones units digit of m, what is m? We have 3 digits, and it's odd, so it's going to be either 1, 3, 5, 7, or 9 for that units digit. Now the other digits, I don't know. I'll just call them A, B, and C. I actually don't know any of the digits right now. Now let's give attention to what they tell me in the question, that the hundreds digit, which in my case is A, is equal to the product of the tens and the units digit. So that'd be B times C. So A is equal to B times C. So we have to now fiddle around with this, see what we get. Let's start with 9. If C was 9, well, if B was 1, A would therefore be 9, and that's not allowed because the digits are distinct. And that would give 2 digits that are the same. If B is 2, well, anytime you go above 1, now 2 times 9 is 18, but A has to be a digit. So that means that 9 is not going to be valid. And for the same reason, 7 will not be valid, and for the same reason, 5 will not be valid, because if you use 1, then you'd have 5, which breaks this rule that they're distinct, and if you choose 2 for B, then you'd have 10, which breaks the rule that A is a digit. So I've got to turn my attention to either 3 or 1. If I choose 3, and I choose 1, again, I have that problem, that it's not distinct, but if I choose 2, finally, we get something that works, 6, 2, 3. And if I choose 3, I would get 3, 3, and 9. That's not distinct. And then 4 would give me 12, which is not a digit. And then with 1, we have the same problem that we would always get two numbers that are the same. For example, if this was 1, we'd get 1, 1, 1. If this was 2, we'd get 1, 2, 1, and that kind of story. So 623 is interestingly the only one that works, and therefore that's the answer. Eleanor has 100 marbles, each of which are black or gold. The ratio of the number of black marbles to the number of gold marbles is 1 to 4. How many gold marbles should she add to change this ratio to 1 to 6? Well, it's 1 to 4. I can also write it as x over 4x. So b plus g would basically be x plus 4x. And that is 100. So that's 100. And therefore 5x is equal to 100. X is 20. So that means we have 20 of the black marbles and 80 of the gold marbles. Okay? So if I want to change this ratio to 1 to 6, that means b over, I have to add a certain number of gold marbles, so let's just say x. And that would make it 1 to 6. Well, b is 20, and g is 80. So I really just have this algebra now. Cross multiply. 20 times 6 is 120, and that's 80 plus x. So x is equal to 40. 40 is the number we have to add in order to change the ratio to 1 to 6. Suppose that n is a positive integer and that the value of n squared plus n plus 15 over n is an integer. Determine all possible values of n. N squared plus n plus 15 over n. Well, break it up into different parts, and that will make your life a lot easier. And when you do, you get the following. So n squared over n simplifies to just n over n simplifies to just 1, and then we just have to deal with this 15 over n. This is always going to be an integer, as long as n is an integer, of course. Well, 1 is fixed as 1. That's always an integer. So I just have to look at this. This whole expression will be an integer if and only if that's an integer. So that means n must be one of the divisors of 15. Well, what are the divisors of 15? Well, 15 is 3 times 5. So the divisors must be 1, 3, 5, and 15. So that means n is equal to either 1, 3, 5, or 15. And what are they saying? Determine all possible values. Well, these are the possible values. Donna has a laser at C. She points the laser beam at point E. The beam reflects off of DF at E and then off of FH at G as shown, arriving at point B on AD. If DE is equal to EF is equal to 1 meter, what is the length of BD in meters? Well, this is 90 degrees, this is 45, so therefore this must be 45, that angle in there. And that means that is an isosceles triangle. They told me that DE is 1, and therefore, since it's isosceles, that means this is 1, C to D. And by the same sort of story, we can figure out the angle here is also 45, and therefore this is isosceles. That is going to be equal to that in terms of the length. EF, they told me, is 1. So that means this is 1. Well, therefore, I can draw a line straight across from C to G like that, because they both have a height of 1. So that line basically will be parallel to DF. And that means that this is therefore a right angle. Now, they have placed 45 there. So since this is also 90 degrees, this has got to be 45. So that means this is also 45, and once again we have another isosceles triangle. That is the same as that. Well, C to G is the same as D to F, which is 2, and therefore B to C is 2. So they want BD in terms of the length. That's going to be BC plus CD and that's 2 plus 1, and that is 3. Ada starts with x equals to 10 and y equals 2 and applies the following process. Add x and y, let x equal the result, the value of y does not change. Multiply x and y, let x equal the result, the value of y does not change. Add y to 1, and y will be the result, the value of x does not change. Ada keeps track of the values of x and y. Now continuing with x equals 24 and y equals 3, Ada applies the process 2 more times. What is the final value of x? Well, let's make a table and off we go. So, shouldn't be that complicated as long as they don't make any silly mistakes. So they've already done the first step. So we are now starting with this. They've done the first process, I should say. Each process has 3 steps. Okay, so let's start with 24 and 3 and do step 1, step 2, and step 3. Okay, so the first step we have to add x and y, so that looks like that's 27. And the value of y does not change. Then you multiply x and y, and that's going to be 81. And the value of y does not change. Then you add 1 to y, that's going to be 4, and the value of x does not change. So that is the next process, I guess. And then now we have to do the process once more. So again, adding x and y, this time we're starting with these guys. So x and y would be 85 if I add them. Y does not change. Multiply now x and y. That's going to be 340. Value of y does not change. And then step 3, you add 1 to y. That becomes 5. Value of x does not change. So they're saying, what is the final value of x? Well, it is 340. Determine all integers k with k not equal to 0, for which the parabola with the equation y is equal to kx squared plus 6x plus k has 2 distinct intercepts. A little bit of a primer in case you have forgotten. As I'm sure you know, this is a parabola, and the quadratic equation is minus b plus or minus the square root of b squared minus 4ac over 2a. Now this usually gives me 2 roots, right? Because it's plus or minus. So that would give me 2 roots. And sometimes it gives only 1 root, and then sometimes it gives me no real roots. So what are the criteria for each of these? Well, it has to do with something called the discriminant. And the discriminant is b squared minus 4ac. That's this guy right underneath the radical sign. When that is greater than 0, you get 2 roots. When that is equal to 0, you get 1 root. And then when that discriminant is less than 0, you don't get any real roots. You get imaginary roots, right? So how many do they want? They want 2 roots. Okay, that means we want the discriminant to be greater than 0. So let's put that into our formula. So using this time, right? So b squared minus 4ac looks like it will be, let's see here, 6 squared minus 4 times k. And we want that to be greater than 0. Okay, so 36 minus 4k squared is greater than 0. 36 is greater than 4k squared. Divide through by 4, k squared is less than 9. So that means that k is less than 3. But remember, plus or minus, don't forget about the plus and minus. So it's got to be greater than minus 3. Okay, and is k an integer? Yeah, k is an integer. So the only possible values for k looks like it's less than, not less than or equal to. Equal to gives me this situation. So k can only be either 2, negative 1, cannot be 0, because they already told you it's not 0. So then it's either going to be 2, 1, negative 1, negative 2. Yeah. So I guess there's only 4 values. And yeah, those are the ones. 2, 1, negative 1, negative 2. The positive integers a and b have no common divisor larger than 1 if the difference between b and a is 15 and 5 over 9 is less than a over b is less than 4 over 7. What is the value of a over b? The difference between b and a is 15, so that's important. That helps us get one in terms of the other. So b I can write as 15 plus a. Or I can write a is equal to 15, b minus 15. Either one. Both of those are valid, of course. Now let's look at our inequality. It's 5 over 9 less than a over b less than 4 over 7. So 5 over 9, I'll just choose the b minus 15 to put for a, and that's over b is less than 4 over 7. So now let's take this one step at a time. Let's look at these two first and see what we get. If I use those and I cross multiply, I get 5b is less than 9b, and then what's that, minus 135. So that means 135 is less than 4b. So b is greater than 135 divided by 4, I think it's 33.75. Okay, now let's look at these two guys and see what we get. So cross multiply and get 7b minus 7 times 15, 105, less than 4b. So that means 105 on this side, 3b on this side, so b is less than 35. Okay, so combining these, b is greater than 33.75 and it's less than 35, and b is an integer. So that means the only possible value for b is 34. Subbing it back into here, that means a is 34 minus 15, so a is 19. And therefore a over b is 19 over 34. I think that's it. I guess the only thing I have to worry about is, do they have any common divisors? And the answer is no, because 19 is prime. All right, that completes 4a. A geometric sequence has first term 10 and a common ratio of a half. Our arithmetic sequence has first term 10, a common difference of d. The ratio of the sixth term in the geometric sequence to the fourth term in the geometric sequence equals the ratio of the sixth term in the arithmetic sequence and the fourth term in the arithmetic sequence. Determine all possible values of d. Geometric arithmetic. So geometric are of the form ar squared, ar cubed, ar fourth, ar fifth, and so on. Arithmetic are of the form a plus d, a plus 2d, a plus 3d, a plus 4d, a plus 5d, and so on. All right, so now let's look at what they're telling us. The ratio of the sixth term in the geometric sequence, that's this guy, so ar fifth to the fourth term, which would be this one right here, ar third, that equals the ratio of the sixth term in the arithmetic sequence, which is a plus 5d, this one right here, to the fourth term in the arithmetic sequence, which is this one, a plus 3d, sorry. Okay, so this hopefully will allow me to solve for d, which is what they want, all the possible values of d. From over here, the a's cancel, and all you're left with is r squared. Over here, nothing cancels, but I can substitute my value for the first term, because I think they told me that. Yeah, the first term is 10. So I can put 10 here. D, of course, I don't know. And that's 10 plus 3d. And I think r, they also told me. It's right here. That is a half. So this just becomes a half squared, which is a quarter. So a quarter is equal to 10 plus 5d over 10 plus 3d. All right, so that I'm pretty confident I can solve that. Cross multiply and you get 10 plus 3d is equal to 40 plus 20d. So minus 30 would equal 17d, and therefore d is equal to minus 30 over 17. There you go. That's the answer.